Hey everybody, it is Mrs. Slauson, and I am here to guide you through your first ICANN assessment so you can get the correct answers. So the first thing that I'm going to recommend is that whenever you see the graph, especially in our first chapter, that you mark those important points and just get used to that. It does help you answer the other questions. So for this arrow, since it's on the left, x is going to be negative infinity, and since it's pointing down, y is going to be negative infinity. On the right side of the graph, x is always infinity, and since it's pointing down, the y value is going to be negative infinity. All right, the other important points, you always need to mark your x-intercept. So this one is 0, 0. This one here is 4, 0, if you note the scale. And then right here where it turns, those high and low turning points, we have 2, 4. So one thing you really had to pay attention to was the scale, that it's going by 2's on the x-axis and 2's on the y-axis. So the first question is, how would you describe the graph? Is it a relation, is it a function, or is it a one-to-one function? So the first thing is I'm going to see everything's a relation until I prove otherwise. So the first test I'm going to run is my vertical line test, which it is passing my vertical line test. It's hitting it once. So right now it's a function. And then I'm going to see if it passes the horizontal line test. If it does, then it gets to be a one-to-one function. So right here, if I just set my pen, this horizontal line is hitting my graph twice. Some of you might notice that the y's are repeating, which cannot happen in a one-to-one function. So this is a function, and the reason why, you might say, is that it passes the vertical line test, but it's going to fail your horizontal line test. And once it fails that, it doesn't get to be one-to-one. All right, state the domain using interval notation. So I want my smallest x and my biggest x. This is a great time to frame it out, if that helps. So framing it out means I just put sticky notes on the left and on the right, because x is domain, and domain runs left to right. And then right where it touches here is my lowest x value, which is the negative infinity. And then over on the right side where it touches, that's my biggest x value, so that's infinity. And so if you want, you can write it like this. Infinity, you do need parentheses. So if you didn't have parentheses, that might be one of the reasons why it was marked wrong. The other option you have is to write that weird R that stands for all real numbers. All right, the next one, the range. So the range is our y's. So I'm going to frame out from bottom to top, because y's run bottom to top. And on the bottom is my smallest y value, which is the either negative infinity. And then my biggest y value is what is going to be on the top, and that's going to be the 4. All right, infinity, again, always has parentheses, but I will be putting a bracket on the 4 because 4 is actually part of the range. I should include it. It is in the range club. All right, number 2, 2A. Your job is to create a one-to-one table. That means a one-to-one function where the domain is the smallest x is -3 and the biggest x is 5. So the easiest way to do that is go like this. And your range, your smallest y is 2 and your biggest y is 7. And to make this easy, first of all, when you put numbers in for the x, which I'm going to point out for some of you, your x's do need to go in order. So you can't do, -3 and then put maybe 4 here and then 0 here. That's not going to work over here. You're going to end up making your function not be one-to-one. So x's always in a table do run in Algebra 2 from smallest value to largest value. So just pick some values that are in between -3 and 5, but then go up. So you could simply do 1, 2, and 3 from there. But don't jump around in the order, because that throws this off. For my y's, I'm just going to do the same thing. I just have to make sure, since it's one-to-one, that none of my y's repeat. So I'll just do 3, 4, 5. And then if you come over here and graph them, so here's -3, 2, excuse me, 1, 3, 2, 4, here is 3, 5, and 5, 7, then you can connect them from left to right, and then it should pass both the vertical line test and the horizontal line test. Now the other option is to do this instead. So let me grab another assessment. And what I'm going to do is frame it out the same way I showed you before. So I'm going to frame out -3 to 5 on the x's. And so nothing over here can exist. And I don't want anything over here. And then I'm going to frame out 2 to 7 here. So there's 2, and there's 7, and I don't want anything above 7 or below 2. And then just draw a shape all the way from the bottom left corner to the top right corner, and make sure it's able to pass the vertical and the horizontal line test. And that was what will keep it 1 to 1. All right, the next thing you had to do was actually give me one additional point. So, sorry, my phone rang. Now what I want to do is just give one more point. So if I were to add another row here, that would make this function not be a function, which basically means it needs to be a relation, which means x needs to repeat. So as long as you pick one of these x's to repeat, I'll just pick 5, then I do need to pick a y that's not 7 because I've just mimicked the same point. So maybe I'll pick 5, 4. And because this 5 is repeating, that is going to make it not be a function at all anymore. So that's the first part. And so you would have had a score here. So again, look at what I circled. And again, I tried to address everything that I thought was missed. And again, over here, a lot of you did a great job, but once you mixed your x's and didn't put them in numerical order, this failed to be a 1-to-1 function, because it didn't pass the horizontal line test. All right, let's go to the back. I'm going to mark up my graph. So this is the left side, so x is -infinity and y is infinity. This is where it's going to end, and I'll just make that 1, 2, 3, 4, maybe 5, -2. And then where it hits the x-axis, so -3, 0, and this is about 1.5, 0. And where it turns. So this is 0, -3, and this is going to be 3, -3. So let's go through this. So for what interval of x is f of x increasing? So what I'm going to do is, while I'm answering increasing, I'm going to throw in there decreasing as I go through this. Okay? So I'm grabbing a pencil, something that I can erase with. So right now, left to right, my graph is my y's are decreasing. Now they're increasing, now they're decreasing, and now they're increasing. And because I'm using pencil, I'll be able to erase this. So here's my first interval for what interval of x, so that's reminding me to use my x's when I answer, is f of x, which is just another way to say y, increasing. So use your x's from -3 to 0. And then the other one is from 3 to 5. And all increasing and decreasing are always in parentheses. So I'm going to erase that now and go to the next question, which has me deal with negative, and its opposite is positive. So where is it negative? Where is it positive? So for what interval of x, again, write your answers with the x values, is f of x or y negative? So going left to right, my y's are positive, then they take a little break, and now they're positive again, still positive. And then in this little part here, this is where they're negative, and this is where I want to write my answer. So using the x values from 1.5 to 5, at 1.5, your y value, because that's what we're looking to see, is y negative. That y is not negative, it's 0. It's not in the negative club, so I don't want to include it in the negative. But when I look at the end, is this y value negative? It is, so I do want to include that part. So I put a bracket to include. All right, just erasing here, we're going to get the next part. So when I give you a number like this is me saying if y is 2, I want to know the x's. So if you just go to where y is 2, that's this line all the way across. So I'm going to draw a little wavy line. This is where y is 2. And I'm just going to write all those x values. So this one is about x is a half. This one is x is -1. And 2 was fine, two numbers, that is. But maybe some of you noticed over here that, this is still moving, but right there is another place where y is 2. And a few of you caught that and actually said the x is, oh, it's not negative 2. 1, 2, 3, 4, 5. Sorry, negative 5. I just needed 2 of the answers, okay? State the domain, again, smallest x to biggest x. You can frame it out, so let's erase that. So here's the right, here's the left, and right where it touches there, that's my smallest x value, so that's negative infinity. And then my biggest x value there is 5. Infinity always has parentheses. 5 is part of the domain. I should include it, so bracket. Find the average rate of change. So just a reminder, this is me telling you the x's, and then you will have to go to your graph and find the y's. So that means we're going to look at negative 4, and that's right here. So that's 1, negative 4, 1. And where 2, there is 2 and negative 1. So from there, the formula, it says you subtract the y's in the numerator, the x's in the denominator. So I'm going to do 1 and subtract negative 1, which gives me 2. And then I'll have to do negative 4, take away 2, and that's going to give me negative 6. So some of you left your answer like this. That's fine. It technically works. Some of you simplified it. And some of you remembered that I like this over 1, so you actually divided it. So all of these are acceptable as far as this showcase of learning went. All right, last question. So stating the range, again, the first thing I'm going to do is mark up my points. Here the graph is on the left, so x is left, so it's negative infinity, but it's going up, so infinity. This arrow is to the right, so x is infinity, but it's going down, so negative infinity. Where it hits the x-axis, so there's negative 1, 0, and 2, 0, and then where it turns, which is 1, 4. So again, mark those points. It really does help the thinking. So stating the range, you can frame it out for y's, and then the smallest y is on the bottom, so negative infinity. That's my infinity sign. I know you can't see that. And then up here is infinity. And some of you might be thinking, well, that's what I have. But what has to happen, I've told you several times, is it's the smaller number first and the bigger value second. So these do have to be written exactly as you see it. Stating the relative max, that is your top of the hill and the bottom of the valley. So this is the only max I'm looking for. And you do have to say it's a max of, and the y value has to come first. Because when you state x first, that's not the max. That's a left or right distance. So max of y equals 4, you could have just said 4. When x is 1. All right, here, since the number's in parentheses, and this is me saying if x is negative 2, what's y? So if you just go to negative 2, you're going to see it's that little dot right there, and that's 4. But I prefer you to put your answer like this. All right, I'm going to save D for last and talk about the end behavior. So this is still new. You just have to fill in the blanks. So basically you look for, in the end, if your x keeps getting bigger and bigger and bigger, which is what's happening here, what would the y's be doing? What would your f of x's keep doing? And that would be a negative infinity. And then this is saying, if your x's kept getting smaller and smaller and smaller like they are over here, what would your y's do? What would your f of x do? And they would keep getting bigger, infinity. All right, the last thing I want to talk about is this. So we didn't really have this pop up, so I took a couple of different answers. When we talk about positive and then negative, we would say, going from left to right now, my y's are positive. But when they get there, they stop being positive. And then what happens is when they take a little break from being positive, they actually start being positive again. So you actually have two answers here. So what I was looking for is from using the x values from negative infinity to negative 1. This always has parentheses, and since this y value is 0, it's technically not positive. I don't want to include it. But then it takes a little break from being positive. and then it is positive again. So I'm going to do this again, but from -1 all the way to 2. And again, here the y isn't positive, so I don't include it. And when I get to the end, the y isn't positive, so I don't include it. That is the better answer. What I did also take was some of you just did this whole stretch from -infinity to 2. And just a reminder, we are talking about is y increasing, is y decreasing, is y positive, is y negative, but we will always use the x values in the description. And that's it.